My name's Chris Meny-Gibert. I was the lead structural engineer, if you like. Did both the structures and a lot of the civil work as well. The superstructure is a steel portal frame. It's a double-story building, so the portal has actually got a floor mid-height. Because of the cladding that was used, a high degree of accuracy was required in both the detailing and the fabrication. I think the first thing was there was an expectation on the part of the architect that the framework should be extremely slender and extremely light. At the open gable ends, you see the thickness of the structure, and he wanted that to have very thin and light appearance. So the difficulty was making sure that we delivered that, but at the same time the structure was sufficiently robust. In other words, there wasn't lateral sway under wind, excessive sway, and so on and so forth. Deflection was one of the main controlling aspects for me, and that was how I arrived at the size of the member I used, which is an IP 200. I wanted the building to be robust. I didn't want significant sway deflections. You know, the body is quite sensitive to that sort of movement. So with a bit of care and sizing, we managed to get that sway deflection down to, as I said, about from the measured the apex of the roof. The sway is 1 in 485 of the height, which is, I think, quite good. The thing that did help stiffen the thing against lateral sway was the mezzanine floor, which we made sure was a moment connection to the columns rather than a pin connection, so that we got that additional framing stiffness. One played around with various modules for the rhythm of the frames, and that also had to tie in with the panel sizes of the cladding, which was quite exacting. So I think the main challenge really was the accuracy with which everything had to be detailed, and the accuracy with which the fabricator had to then provide the end product. All of the secondary members, the cold form sections, which are the purlins and the rail holding the cladding, are actually cut between the portal frames. We pulled everything down to the absolute minimum of thickness. That called for quite tricky detailing, and we delivered a lot of details to the fabricator. We didn't leave it to the fabricator because everything had to be so exact. We actually detailed virtually every connection in that building. So I think we would be fairly proud of that, and hopefully it would be recognized by another engineer. I don't know. A high degree of accuracy was called for. In steel, you can actually deliver that accuracy because it's all done in the shop. It's done to high levels of accuracy in fabrication and so on. And you have a chance on site to erect it to that same exacting accuracy. So it suited, from that point of view, it suited the project very well because of the cladding panels were detailed to within millimeters of width and tolerance. It also had the benefit of speed of erection. We were under tremendous time constraints on the job, so it had that benefit as well. I think be able to give the architect what he wanted, to achieve. That was really, and that is what I see my primary function very often as being, to try and assist in realizing the concept and the vision. I just think it was very demanding, and we delivered a very, I think, precise and neatly detailed end product. I think the architect did a very good job. Okay, I mean, primarily I think it's his creation, and I think the use of steel was highly appropriate for the purpose, and I think that we helped deliver it. But I mean, it's really the architect's vision, and I think he did a good job on it.